All right, class, we're going to introduce logs here. And as it says here, a log is another way of writing exponents. So we have a logarithmic form and exponential form. So there was a way to try to figure out how to solve logarithmic problems pretty recently, actually. And they came up with this log form as an inverse to the exponential form. All right, so this helped solve complex equations that involve the exponents. All right, so we have the log, and it's read as log base b of a equals x. All right, and then we can convert it into its exponential form by doing this. So we know an exponential has a base, so that's what b is. So whatever that number is, we'll put that base there. And as we know, the exponent is up in the power, and logs equal the exponent. All right, so that is going to be at the top there. And then we have a number a, which is something we call the argument. Okay, and basically it's just usually a number. It could be an exponential, but you can call it different things. Okay, so there is our conversion from log to exponential form. So here's another way that I teach, and it can kind of help in doing these conversions. All right, and I call it like the Ben method. You just got to remember Ben, B-E-N. Couple of things though. I kind of write them differently to do this. So we have log base b of n. This is our argument. So I'm basically replacing a with n. Okay, so n for number equals the exponent. Okay, and then we can convert them back and forth by remembering Ben. We're just going to spell it out. B for the base, e is the exponent, and equals the number. Could have capital B here. All right. So let's kind of just go through what these are. So B is your base. Okay. E is your exponent. And N is the number. Now remember, this number can also be a variable, but whatever it is, something that we call the argument. Okay, there's also other logs. All right, there's something called a common log. All right, and that's just a log that has a base of 10. All right, and it's equal to a log without a base. So the common log is basically a shorthand way of writing base 10, which you just don't write it. So when you see a log that has no base there, it's assumed to be 10. All right, and basically it's common. If you look at your hands, how many fingers do most people have? We have 10 fingers. A lot of our counting are in 10 repetitive sets of 10, which is a base 10 system. And that's what logs do. They help us establish those bases for different number systems. All right, so that's why it's a common log. Most people have 10 fingers. That's why our numbers are based that way. So if you think about, like, if you were an alien and say you had 3 fingers on each hand, what would your number system probably base off of? Probably a base 6, because there's 3 fingers. Clocks that when we tell time with are off base 12. Okay, so that's another purpose of the log. Another log we're going to see is something called the natural log. All right, and that is a log that has a base of an e. Oops, sorry. Let's just not write that e. All right, so the base e is just a number. So when solving exponential equations and doing different tasks with exponentials, this number occurred naturally. So that's why it's called natural log. So this number, this e, kept appearing, so we just called it e, which was just a natural base of logs. And this just occurred in nature. So it's just a common thing, kind of like how pi just kind of occurs. So that's one of those constants that we keep finding. All right, so there's a bit about bases, and there's some other things on bases there, which will have another video done by a lady, Mr. Moreno found, that's very informative and very good, better than I can do. So that'll be in the assignment as well. All right, so let's go ahead and start converting some of these things. And I'm going to use my Ben method here. All right, so it just depends on where we're going to go. We're going to go back and forth. We're going to go from exponential form to logarithmic form here. All right, so and it's real quick and it goes pretty fast. So write each equation in exponential form. So what we're going to do is we're going to put it into bin. All right, that's the exponential form. So first, we got to look at our base. So first one, log base 3 of 9 equals 2. So our base is 3, right? So we're going to put 3. Our exponent, logs equal the exponent, and just look at your conversion here. All right, so e goes in the power. What's the e? It's going to be the 2. All right, and then what's the number? The number is the argument, and that's going to be 9. And that's it. We converted it to exponential. All right, so let's look at this one here. So again, what's the base here? Put b there for 6. This is the number, and this is the exponents. Logs always equal the exponents, kind of how I remember it. So base is 6, exponent is 3, argument is, the number is 216. All right, and if you put in your calculator 6 to the third power, you're going to get 216. So that's why it's the equals there. A couple of other ones. So this one's log base 7 to the 0 equals 1. That makes sense. We should all know anything to the 0 power equals 1. All right, this one here is log base 2 to the 4th power equals 16. All right, this one's log base 4. All right, so now be careful. This negative 2 goes up top, and it's going to equal 1/16. So you can just leave them as fractions, keep the negative with it. And 27. So we got log base 9 to the 3/2 power equals 27. Now, is that true? Well, convert it. As we did in the previous lesson, square root of 9 is 3. 3 cubed is 27. So that works out there. All right, so now we're going to write each equation into logarithmic form. We're just going to go the other way, and this time we're going to write this out. Log base b equals e. Oh, b of n. Equals e. There we go. All right, and again, just going back and forth from this conversion here. So again, if we know what our base is, or our number and our exponent is, we're just writing it differently. Okay, so exponentials, we have the 14 is our base, okay? The 2 is obviously the exponent, and this is going to be our number, all right? So to write it as a log, first we're going to write out log. Our base is 14, put the number in, I like to use parentheses, and equals the exponent, which is 2. All right, going on to here, okay? This is going to be a log base 3 of our number, which equals 4. So logs always equal the exponent there. 3d1. All right, let's go on to this one. All right, so log base 12 of 12 equals 1. All right. So, and then we should know, like 12 to the 1 power is just going to be 12. It's going to be itself. All right. Log base 36 of 6 equals 1/2. Okay, square root of 36 is 6. Let's see. Log base 2. Well, let's talk about this one too. Of 1/8 equals -3. All right, so let's talk about base 2. That's another common log, or not common log, but a log we see a lot because that's basically binary systems. So computers work with number systems that are base 2, 0 and 1, and different combinations of that. So that's a very important one, especially those of y'all looking to go into the to the tech industry. Okay, so binary systems are base 2 type numbers. That's what all our phones run off of and things like that, the very low machine level. All right, and 12. Let's convert this one. So log base 8, 16 equals 4/3. So once you get the hang of it, you can write these out pretty fast. You need to use that equation quite a bit, so to have that handy to look it over. All right, one other thing I want to do is, of course, do some Desmos evaluations with our calculator, if I can find it. There it is. I'll show you how to do some calculations using Desmos. All right, so let's do different log evaluations. So let's say we're going to do the log of 16 equals 64. So what I'm going to do here is I'm going to go go ahead and type out log. All right. And then we're going to do the, just look at the functions here. Probably should have done that first. I had TI on my head. All right, so let's see. Let's find logs here. Under miscellaneous, probably. There it is. All right, see, let's put B down there. And we're going to want to press this button here. So how did I get there? So go to ABC, there's A subscript B, and that's where we're going to put our different base. So what we're going to do is log base 7 of 49. All right, so we're going to put 7 for the base. All right, then we're going to arrow into the argument. So in this parentheses, the argument. So that's how I like to write it, with the parentheses. I'm going to put 49. We start introducing variables into there. Parentheses become very important because what's inside and outside the variables, if you already know from last lesson, govern whether it moved up or down, or left or right. So kind of important. All right, and it tells you it's 2. All right, so that should make sense because 7 squared is 49. All right, so that's how you do the log. Let's try another one. Hit enter. Let's do a common log. So common log is base 10. So that's what they give us here. Oh, here's the button right here, right next to it. If I just open my eyes. Okay, so there's a log, and it already has that subscript. So again, just go to log there, and then you get your subscript already. It's much easier. Okay, so let's do a different one. Let's do common log. Let's do base 12. The common log of 12 equals 1, or of 1. All right, arrow in. Let's put 1 in there, and we get 0. All right, so again, 12 to the 0 power would be 1. Remember, anything to the 0 power is 1. Okay, so let's try common log. So functions, and if you just press the regular log, that is our common log. That's base 10. All right, so let's see, common log of, let's put 100 in there. All right, so even though it's not written, it's base of 100, and then it equals 2, okay, because 10 squared is 100. All right, so enter. Let's do common log of, not common log, let's do log E. Let's do a natural log. Let's see if it has it here. Let's see, we're gonna need this one. Oh no, they have it here. So ln is natural log. All right, so this is with base E here. And then we can just pick a number. Let's just say 45, we'll probably get a decimal. And there we go. So that's a natural log, and E is a decimal number. So let's go back to the notes here because it completely slipped my mind. Log base E of x, and that's what it was supposed to equal. And I kind of had a brain hiccup there, brain fart. Is written ln x, and that's what you'll see in your calculator. So if you see E, and then calculators are built in inverse, the inverse to E is ln. All right, and the inverse to natural log is base 10 exponential. All right, so that pretty much covers how to do that, and then the decimals calculations here. All right, guys, good luck. Have a good weekend.